Okay, welcome to Chapter 8. This is day 1 of Section 3, and we'll be spending some time on here. Definition of a solid. The volume of a solid, definition, volume of a solid. The volume of a solid of a known integrable cross-section area from A to B is the integral A to B. Here's what that basically means. Let's say we just had some cylinders here, and they were stacked on top of each other to ultimately they're taking the shape of a cone, and all these guys are just little cylinders on each other. So if we were dealing with this cone right here, we could say the volume of that cone is approximated by the area of all of these cylinders. And that's really what they're saying. We're just working on an additional dimension. So how to find the volume? By the method of slicing. Sketch the solid in a typical cross-section. This is like a cross-section would be a circle here, just a circle of this disc. Excuse me. Find a formula for the area, in this case of that circle. Find the limits of integration. That would be, in this case, how tall this figure is, and integrate the area to find the volume. Okay, so we have some warm-up problems to this, and some of this is just going to be testing our drawing skills, which I'm pretty limited on, and some of you will do a better job with this than I do. Find a formula for the area of X of just a cross-section. We're not doing any integration now. We're just finding the area of a cross-section of solid that are perpendicular to the x-axis. So the solid lies between planes perpendicular to the x-axis at x equals -1 and 1. The cross-sections perpendicular to the y-axis between those planes run from the semicircle. If I take either of these equations and square them, I get y equals 1 minus x squared. Both of these become that. And if I add x squared to both sides, we see it's y squared. We get y squared plus x squared equals 1. So what we're dealing with here, and there are different ways to draw these, and we may talk about doing these with diagonal axes, but for right now we're just going to do this. So I have this semicircle, that way they're written as functions, so we're dealing with this circle, just unit circle, and it says the cross sections are circular discs with diameters in the XY plane. So our cross sections are just circles. So here's a typical cross section right here. So how would we define the area of that cross section? I mean, we can pick any cross section, just kind of like taking a slice through this orange, open it up, we've got a circle. So the area is pi r squared. But in this case, what is our value of r? That's the height of the function, and the height of the function is this guy. So we get area equals pi times square root 1 minus x squared squared. That's our radius. Or area equals pi times 1 minus x squared. You want to distribute that? You can. Sorry, I got a little bit of a cold here. Okay. The cross sections are squares. So once again, we're going to draw that picture. We're still dealing with this unit circle. The cross sections are now squares, so I've got, this is a square here. I've got this kind of look. Trying to give it a little bit of a dimension. So what do I know about the area of a square? The area is just side times side, or side squared. But in our square, if this is side, that side length is 2 of these. And each of those is this long. So we need 2 of those. That is 2 times square root of 1 minus x squared. That's our side length of our squares. Therefore, our area is 2 times square root of 1 minus x squared times the other side, or 4 times 1 minus x squared, square units. You can distribute that if you like. Okay, so ultimately what we'll be doing with this is we'll be taking this thing and maybe integrating that from -1 to 1 to add up all the squares that would fit on that. And we'll talk more about those shapes as we move on. The cross sections are squares with diagonal in the xy plane. The length of the square is diagonal. We shouldn't need that hint. So once again, we'll go back to our unit circle. And now we've got something like, this is the diagonal of a cross section. That cross section might look like that. But we still have a square. There's still squares. And in our square, I'll use this over here, we know that the length of the diagonal is 2 of these. So the diagonal is 2 times root 1 minus x squared. Well, if this is a 45, which it must be, and a 45, to get to the length of the side, it's shorter. I divide by root 2 to get to the side length. So the side length is 2 times square root 1 minus x squared on root 2. Therefore, our area of our square is 2 times square root 1 minus x squared on root 2 squared. So let's see what we get here. I get 4 divided by 2, 2, and 1 minus x squared square root times squared is 1 minus x squared. Okay, the cross sections are equilateral triangles. This is going to call on a lot of our geometry skills and area formulas that we've known in the past. But again, I'm going to go back. I'm going to redraw. You got to get good at drawing these things, or at least adequate at drawing these to show our understanding. So here's my cross section, but it's now an equilateral triangle. So if I take this equilateral triangle, once again, this is square root of 1 minus x squared. This is square root of 1 minus x squared. So this length is 2 times square root of 1 minus x squared. Now we're dealing with an equilateral triangle. This is a 30, 60, 90. This length right here is just one of those 1 minus x squareds, meaning this length is root 3 times square root of 1 minus x squared. Our area formula we can use is 1/2 base times height. Therefore, area is 1/2 the base, 2 times square root of 1 minus x squared. The height, root 3 times square root of 1 minus x squared. 1/2 times 2 cancels. I end up with a root 3, and square root times square root is just plain old 1 minus x squared. And there we have section 1. At that point, so going to be a lot of drawing going on with this, falling back on geometry, and just learning to be able to visualize these. So that is section 1. There are the assignments that they feel now you should be fairly at least informed on how to go about those, and we're gonna have to spend some time talking on them. Section 2, we'll be putting that together in the next day, so make sure to follow along.